In this lesson, we're going to look at some properties of real numbers. So all the properties that we're going to look at today, these are things you would have learned in pre-algebra or algebra 1. They're very, very simple, just things that we need to know to be successful in our course. So we're going to start by just talking about the commutative property of addition and multiplication, and we'll begin by focusing on just the commutative property of addition. So this rule basically tells us that we can add in any order. So for example, if we see something like 5 plus 9, we could rearrange the add-ins. Remember, add-ins are what we refer to as the numbers being added together. So we could rearrange the add-ins. So we can say 9 plus 5, and the result will be the same. 5 plus 9 is 14. Also, 9 plus 5 is 14. So changing the order did not change the result. Right? 5 plus 9 equals 14. And also 9 plus 5 equals 14. Now, this extends to all real numbers. So if I'm working with negatives, decimals, fractions, whatever it is, the same rule applies. So as an example, if I had something like negative 7 plus negative 3, this is equal to or the same as if I reordered the add-ins and said negative 3 plus negative 7. Either way, I would get negative 10 as a result. Right? So negative 7 plus negative 3 is negative 10. And of course, negative 3 plus negative 7 is also negative 10. Right? Same thing either way. This property also extends to more than just two numbers. If I'm only performing addition, then I can add in any order that I'd like. I could have 4 trillion numbers. I could change the order up as much as I want. I will never change the result. So as a quick example of this, suppose we had something like 4 plus 2 plus 7. So we can say this is equal to what? 4 plus 2 is 6. 6 plus 7 is 13. Let's just say I changed it to 4 plus 7 plus 2. What do you expect? Again, you'd expect an answer of 13. 4 plus 7 is 11. 11 plus 2 is 13. And let's just do one more. So let's just say we put 2 first. So 2 plus, let's say 4 plus 7. Again, we'd still get 13. 2 plus 4 is 6. 6 plus 7 is 13. So just to kind of recap this property, the commutative property of addition just tells us that we can add in any order, right? We'll never change the result. So when we think about the commutative property of multiplication, it's the same thing that we saw with addition. We can multiply in any order. We won't change the product. So if we had something like 3 times 9, we could rewrite this, or we could change the order of the factors, right? The numbers being multiplied together are known as factors. So we could say 9 times 3. And 3 times 9 is 27. And 9 times 3 is, of course, also 27. Again, this property extends to all real numbers. So if you're working with decimals, if you're working with fractions, negatives, positives, whatever you're working with, it will not change because you change the order of the multiplication. So if I had something like negative 1/5 multiplied by, let's say 2/7, this would be equal to 2/7 times negative 1/5. In each case, if I have negative 1/5 times 2/7, negative 1 times 2 is negative 2. 5 times 7 is 35. If I did it this way, 2/7 times negative 1/5. Again, 2 times negative 1 is negative 2. 7 times 5 is 35. Either way, you're getting negative 2/35 as a result. All right, so the next property we want to cover is known as the associative property of addition and the associative property of multiplication. So the associative properties allows us to group the addition or multiplication of 3 or more real numbers in any order. So if I'm only performing addition, I can group the add-ins however I want. If I'm only performing multiplication, I can group the factors however I want. So let me give you an example. So for the associative property of addition, let's say I had something like negative 9 plus, let's say, the quantity 5 plus 7. So I can say this is equal to the quantity negative 9 plus 5, then plus 7. We know from the order of operations that whatever is inside of parentheses gets evaluated first. So on the left here, this would be evaluated first. On the right, this would be evaluated first. What our associative property tells us is that it doesn't matter you're going to end up with the same answer either way. On the left, if I have negative 9 plus the quantity 5 plus 7, 5 plus 7 done first is 12. So you'd have negative 9 plus 12, which gives us positive 3. If I look at the one on the right here, I have the quantity negative 9 plus 5. This is done first, and then plus 7. So the quantity negative 9 plus 5. So negative 9 plus 5 is going to give me negative 4. So this is negative 4 plus 7. And negative 4 plus 7 is also 3. So you can see that changing the grouping, or changing which add-ins we had parentheses around, did not change the result. All right, let me give you another example of this. So for addition, let's do the quantity 14 plus 2, and then plus 11. Again, we could rewrite this by shifting the parentheses, so I can put 14 plus the quantity 2 plus 11. You may see some practice exercises like this. If you're taking a more advanced course in algebra or pre-calculus course, typically in the beginning of the course, in the review section, you will see this property addressed. So if you saw something like this and they said, hey, use the associative property of addition to rewrite this, it's just what I did. So you would take 14 plus 2 plus 11. You just shift where the parentheses are. So if it's around 14 plus 2, you now put it around 2 plus 11. Okay, that's all they're looking for. And again, to prove that this is a valid property, if I evaluate the left side, what do I get? 14 plus 2 done first is 16. 16 plus 11 is 27. On the right side, 2 plus 11 done first is 13. 13 plus 14 is also 27. So no matter what you put the parentheses around, you get the same result. Again, this is what the associative property of addition is telling us. Now, for the associative property of multiplication, it's essentially the same principle. So we can group the multiplication of 3 or more real numbers in any order and not change the product. So something like 4 times 3 times 7, where we have parentheses around 4 times 3, would be equal to or the same as 4 times 3 times 7, where parentheses are around 3 times 7. Again, with the order of operations, we know on the left we do 4 times 3 first because it's inside of parentheses. 4 times 3 is 12. So I would have 12 times 7. And 12 times 7 is going to give us 84. On the right-hand side, I do 3 times 7 first, so that's 21. So I'd have 4 times 21, and 4 times 21 is also 84. So again, it doesn't matter what we put parentheses around or how we group this multiplication. The associative property of multiplication tells us that we're going to get the same answer either way. All right, let's look at a quick exercise here. So the problem tells us to use the commutative property to simplify each. So we have negative 10 multiplied by x multiplied by 4/5. So the idea here is that if I want to simplify this, I want to multiply this number here by this number here, right? I can't really do anything with that x there to simplify other than put the x next to the number. So what I'm going to do is just reorder the multiplication. So I'm going to write this as negative 10 multiplied by, I'll just switch the position of this and this. So 4/5 then multiplied by x. So now that they're next to each other, I can multiply. So negative 10 divided by 5 would give me negative 2. And then, of course, negative 2 times 4 would be negative 8. So this would end up being negative 8x. So this is something we do without even thinking about it, right? If we saw this problem and you didn't even know about the commutative property, you would know automatically that you can just straight up multiply negative 10 by 4/5, take that result, which is negative 8, and just multiply it by x to simplify the problem. All right, for the next problem, we want to use the associative property to simplify each. So we have 5 plus the quantity 3 plus x. So the idea here is that I can add 5 and 3, but I can't add x to any of these numbers, right? It's not going to combine. They're not really like terms. So I can switch the parentheses here and put the parentheses around 5 plus 3 and then plus x. I can now combine 5 and 3. 5 plus 3 is 8. So I can write this as 8 plus x, or we can just switch that around and put x plus 8. So next, let's talk about the identity properties. So the identity properties state special properties of the numbers 0 and 1. And we're going to use these when we're solving equations. So we first have 0 is the additive identity. Okay, 0 is the additive identity. So adding 0 to a number leaves the number unchanged. Now, you might think this is very obvious, but when we're solving equations, a lot of times we end up saying x plus 0 equals what, and students get confused. X plus 0 just equals x, right? Adding 0 does not change the value of this no matter what x represents. It's just like if I had 5,300,000 and I added 0, what's the result? It's just 5,300,000. Right? Adding 0 to something does not change it. That's why it's known as the additive identity. All right, next we have 1 is the multiplicative identity. So multiplying 1 by a number leaves the number unchanged. So if we looked at an example of that, let's say we had something like negative 558 times 1. What's the result? It's negative 558. Again, when we're solving equations, a lot of times we'll end up with 1 times x. What is this? 1 does not change x when it multiplies it. 1 times x is just x. And you also need to think about this because a lot of times if you see a variable by itself, you need to know that it has an implied coefficient of 1, right? Because I can always write x as 1 times x. All right, so the inverse properties tell us that each real number has an opposite, or some people call it a negative or an additive inverse. There's a few different ways you can kind of describe that. And each non-zero real number has a reciprocal. So when we add a real number and its opposite together, the result is 0. So first off, you know a number is an opposite of the other if the absolute value of the number is the same, they just have different signs. So in other words, 3 and negative 3, or 2 and negative 2, or 117 and negative 117. So the number part is the same, it's just the sign is different. You have a positive and a negative. When you sum two opposites together, you're going to get 0. So if I add 3 plus negative 3, what do I get? I get 0. If I add 2 plus negative 2, what do I get? I get 0. If I add 117 plus negative 117, you guessed it, we get 0. So why is this useful? Well, if we're solving equations, and let's just say we have something like x plus 4 equals 2. I know that I want to get x by itself. And I know I need to get rid of this 4 here. So if I need to get rid of the 4, what can I add to 4 to make it go away? Well, I can add the opposite of 4, negative 4. So I would say x plus 4 plus negative 4 is equal to, we'll talk more about this rule later on. We're going to review solving equations. But essentially, whatever I do to the left, I've got to do to the right. So I'm going to add negative 4 to the right side as well. And so what do I have here? Negative 4 plus 4 is 0. So x plus 0 equals 2 plus negative 4. 2 plus negative 4 is negative 2. Now, we just talked about the fact that 0 is the additive identity. So x plus 0 is just x. So this gives me x equals negative 2, and that's the solution for my problem, right? If I had negative 2 plus 4, I would in fact get a result of 2. So next, when we multiply any non-zero real number and its reciprocal together, the result is 1. So hopefully at this point you know what a reciprocal is, and basically to find the reciprocal of a number, if it's a fraction, you can just flip the fraction. If it's not a fraction, you would write it as a fraction and then flip it. So in other words, if I had the number 5, I could write this as 5 over 1. I would flip it. So in other words, the numerator would go into the denominator would go into the numerator. And if I multiply these two guys together, I should get 1, right? A number times its reciprocal is always 1. So 5 over 1 times 1 over 5. What's going to happen is this guy will cancel with this guy, and I'm going to be left with just 1, right? That's going to be my answer. And this is true anytime you multiply a non-zero real number by its reciprocal. So let's just say we had something like negative 3/7, and I multiplied this by 7 over negative 3. You can see that this 7 would cancel with this 7. This negative 3 would cancel with this negative 3. You basically have 1 times 1, or just 1 as a result. So again, we're going to use this when we're solving equations. And let's just look at an example real quick. Suppose we had something like 1/4 times x is equal to, let's just say 12. Well, if I want x by itself, what can I do to get rid of this 1/4? I'm not in a situation where I can really add things because this is multiplication here. So what can I multiply by 1/4 to make it not 0, but 1, right? Because if this over here was 1x, it would just be x, right? We talked about that earlier. So if I multiplied 1/4 by its reciprocal, which is 4 over 1, I would accomplish that because this would cancel with this, and I'd basically have 1x on the left-hand side. To make this legal, I'd have to also multiply by 4 over 1 over here. 12 times 4 is 48, of course. So we would get 1x is 48 or just x is 48. And again, if you wanted to check that, you could say, well, 1/4 times 48, 48 over 4 is 12. So yes, this is true. 48 over 4 does equal 12. All right, let's look at some examples. So we're going to use the inverse and identity properties to solve the following equation. So we have x plus 15 equals 12. So what can we do here? We have this 15 that is being added to x. What can I add to 15 to make it go away? What can I add to 15 to make it into a 0? Well, I can add the opposite of 15 or negative 15. Again, remember the additive inverse property. So we would have x plus 15 plus negative 15. Whatever I do to the left, I also do to the right. So 12 plus negative 15. And 15 plus negative 15 is 0. So I would have x plus 0 is equal to 12 plus negative 15 is negative 3. We know that x plus 0 is just x. So I have x is equal to negative 3 as my answer. Does this work as a solution? Negative 3 plus 15 is 12. All right, let's look at the next one. So we have use the inverse and identity properties to solve the following equation. We have 8x equals 40. So what can we do here? We have multiplication. So 8 multiplied by x equals 40. Again, in this situation, I don't want this to end up being 0 because 0 times x would be 0. My variable would be gone. What I want when I'm thinking about multiplication, I want the left side to be 1x because 1x is just x. So what can I do here? If I want this guy to turn out to be 1, I can multiply it by its reciprocal, which is 1/8. To make it legal, I'd have to do that on this side as well. And what would happen is this would cancel with this and give me a 1x. And over here, this would cancel with this and give me a 5. So I'd have 1x equals 5 or just x equals 5. And if you check this, if I had 8 times 5, that would be 40, right? So 8 times 5 would give me 40. All right, so lastly, let's talk about the distributive property, which is a very important property in mathematics, something we use all the time to simplify and solve equations and just everything. So the distributive property allows us to distribute multiplication over addition and subtraction. We will use this property when we need to change a product into a sum. So right now, if I look at this guy, I have 3 multiplied by the quantity 4 plus 5. So this is a product. I can change this into a sum by distributing the 3 to each number inside of the parentheses. So 3 multiplied by 4 plus 3 multiplied by 5. So 3 times 4 is 12, plus 3 times 5 is 15. This would give me 27. You might say, well, why in the world would you do that? You could just add inside the parentheses first. 4 plus 5 is 9, then multiply by 3 and get 27 much quicker. That's true, but in the case where you have something like a variable involved, you won't be able to do that. So let's say I had 3 times the quantity 4x plus 5. Well, now I can't sum 4x and 5. If I want to change this guy from a product to a sum, my only option here is to use my distributive property. I would take 3 and multiply it by 4x and get 12x, and then plus 3 would be multiplied by 5 to give me 15. So I've changed it from 3 multiplied by the quantity 4x plus 5 into a sum where I have 12x plus 15. This is going to be something we do very often in algebra. We're going to kind of move things back and forth between one form to another. This will allow us to solve equations. It'll allow us to simplify or just do a variety of things that we need to do. All right, so lastly, let's talk a little bit about factoring. So with our distributive property, you saw that we can write a product as a sum, but there's an equality involved there, so we can also use the distributive property to write a sum as a product. So when we go in reverse, we refer to this as factoring. So what we would do here, let's say we have this problem, 8x plus 24. We would look for what's common to each term. So between these two, we know that they have a common factor of 8. So I would start by just writing this as 8 times x like this, and then plus 8 times 3, right? 8 times 3 is 24. And let me write this in a different color so it's really clear what's going on. So 8 and 8. Now, what I can do is I can pull the 8 out from each and place it outside of a set of parentheses. And inside the parentheses, I'll have what's left. So if I pull the 8 out here, I'd have an x. So I'll have an x and then plus. If I pulled the 8 out from here, I'd have a 3. So 3, and then close my parentheses. And the great thing about this is you can check it really easily. If I went back, 8 times x is 8x, and then plus 8 times 3 is 24. So this is basically factoring or reversing the distributive property. If I saw 8 times the quantity x plus 3, I know I could write it like that. If I saw 8x plus 24, I know I could write it like that. So essentially, because of the equality, I can write a sum as a product and a product as a sum. All right, so let's look at a sample problem. So we want to use the distributive property to rewrite each product as a sum. We have negative 2x multiplied by the quantity 4 minus y. All we're going to do is just distribute. So this guy is going to get distributed to each term inside the parentheses. So negative 2x multiplied by 4 is negative 8x. And then negative 2x multiplied by negative y would be positive 2xy. So this turns out to be negative 8x plus 2xy. And again, if I saw just this, and if I was asked to factor, I could rewrite it as this, right? I can take my sum and write it as a product, or I can start out with a product and write it as a sum. All right, last problem. We want to use the distributive property to rewrite each sum as a product. So we have 25x minus 10. And the first thing we want to do if we want to factor this is think about what's going to be common here. I only have an x in one of the terms, so that's not going to be common. So just think about the number parts. 25 is 5 times 5. 10 is 5 times 2. So let's write this to where we have 5 multiplied by 5 minus, we're going to have 5 times 2, right? The 5 is what's going to be common to each. And let's not forget our x right here. So let's put is equal to, I'm going to pull out this 5 from each term. And I'm going to place that outside of a set of parentheses. So my 5 will be outside. And inside the parentheses, I have what's left. So here it would be 5x, right? So I'm going to write 5x here, and then minus. Here I would just have 2. So put the 2 there. So we have 5 multiplied by the quantity 5x minus 2. That is the factored form of 25x minus 10. Again, if you were presented with this, which is a product, 5 multiplied by the quantity 5x minus 2, you could write it as a sum as 25x minus 10. And then, of course, if you have 25x minus 10, like we saw in this problem, you could write that as a product as 5 times the quantity 5x minus 2.